students, welcome to the video. Our topic of today is work. Students, for a layman, work means to do something. But in physics, work has a specific meaning. In physics, work is done when there are two conditions. Number one, when force is applied on a body and body covers some distance, then we will say that work is done. So work is done in physics when there is force, when force is applied on a body, and due to this force body covers some distance. Students, work is the product of this applied force and the displacement of the body through which the body is moved. So the product of this force and displacement is called work. Students, if a force F is applied on a body and body is displaced through a distance s in the direction of force, then by the definition, work done will be the product of force and displacement. If we represent work with W, F is for force and S is for distance or displacement, then it is the mathematical form of work done. W is equals to F multiplied by S, where F is the applied force and S is the distance. Students, work is a scalar quantity. You know, scalar quantity is one which does not need any mention of direction. So work is a scalar quantity and it is measured in the units of joule. 1 joule will be the work done when a force of 1 Newton displaces a body through distance of 1 meter. So it is the definition of 1 joule. Students, when force and displacement are not in the same direction, then what will be the situation of work done? The case that we discussed, in this case the force and displacement were in the same direction, but now if situation is this, that force is and displacement are not in the same direction, or means that how the work done depends upon the angle between force and displacement. Students, let us consider a situation in which force is applied on a body and body does not move in the direction of force. Look at this diagram. If F is applied on a body and body is displaced to the distance S, F and S are not in the same direction. If theta is the angle between the direction of applied force and the direction of displacement, then in this situation we can calculate the work by this formula. What is this? Work will be now the product of force, displacement and cos of the angle between force and displacement. Or in other words, the component of the force which is in the direction of displacement, that component will be multiplied with force. Then we will get work done in the situation when force and displacement are not in the same direction. Now look at this equation, students. Work done depends upon three things. Number one, how much is the force, what is the displacement, and what is the angle between force and displacement. If there is no force, there will be no work done. If force is there but body is not moving, no displacement is there, then there will be no work done. Now what is this third thing? That is the angle between force and displacement. Now let us discuss it in further detail. Means dependence of work on angle. Look at this equation for work done in case when force and displacement are not in the same direction. Students, there are different situations. Considering them one by one. Number one, when theta equals to 0, it means when angle between force and displacement is 0. Look at this diagram. When force and displacement are in the same direction, then what will be the work done? Students, when theta is equal to 0 in this equation of the work done, when we put 0 in the place of theta, we will get cos of 0. You know from trigonometry that value of cos of 0 is 1. So this term of the portion of the equation will become 1 and W is equal to Fs. Students, we say that the work done is maximum when force and displacement are parallel to each other. When displacement is in the direction of force, then work done is maximum. Second case, when theta is 90 degree, it means that when force and displacement are perpendicular to each other. This is the case. Then what will be the work done? Student, here angle is 90 degree. Between force and displacement, angle is 90 degree. Therefore, cos of 90 equals to 0. Putting this value of cos theta here, we will get work done equals to 0. Students, third case, when theta equals to 180 degree. What do you mean? When force and displacement are opposite to each other. In this case, since force is a vector quantity, displacement is a vector quantity, when the directions are altered, when the directions are opposite, sign will also be opposite. So, cos of 180 degree is equals to -1. Putting this value here, we will get negative work. Now students, let us consider the examples of each of these cases. When force and displacement are in the same direction, the work done is positive. In daily life, when we push something, it moves in the direction of force, then we say that the work done on the body is positive. Here is the second case, when force and displacement are perpendicular to each other. Now it is special case. Students, look, there is force, there is displacement, but still there is no work. Here work done is 0 due to the direction in which force is applied as compared to the direction of motion. When force is applied perpendicular, angle is 90 degree, cos of 90 is 0, work done will become 0. In daily life, the work done by a centripetal force is 0 because here this condition applies. Force and displacement are perpendicular to each other, no work is done. Third case, when they are in opposite direction, when we apply brakes on a moving vehicle, it slows down. Force of friction, that is acting opposite to the direction of motion, that is doing the work, that work is negative. Students, this is all about the concept of work in physics. Students, thank you very much for sparing your time to watch the video. If you liked the video, don't forget to subscribe the channel. Thank you very much. Take care of you. Goodbye.